He has a lot of energy, and probably it's because he listens to ska punk. His favorite movie is Anchorman. You probably know it, and he's just an incredible guy. Phil Nash, everyone, give a warm round of applause.
I guess we're running up against the end, so I better get cracking. Hi, everyone. Thanks so much for sticking around for presumably the Fire Pirate film later. But we've got a talk to get through first, so let's do that. My name's Phil Nash. Thank you for the lovely introduction. I'm a developer evangelist at a company called Twilio. Can I ask quickly who's heard of Twilio at all before? All right, cool, a few people, that's exciting. For anybody who hasn't, because there were some hands down, Twilio is a communications platform for your applications to connect or communicate with your users via voice, video, or messaging, using the tools, languages, and frameworks that you already know. I'm not obviously going to talk about Twilio for today, but if you have any questions, do find me afterwards. I'll be happy to answer any of them that you have. What I wanted to talk about, of course, is a little bit of a departure, actually, I think, from some of the things we've seen today. I'm not going to mention Firebase, aside from in this sentence. I'm not going to mention Angular, anything like that. I'm not going to mention progressive web apps, even though I absolutely love them and we should all be building them. What I'm here to talk about is abbreviations. Yes, I have got a lot of abbreviations to give you here. First up is JWT. It was in the title. It's JSON Web Token. So that's an abbreviation inside an abbreviation, just for you abbreviation fans out there. JSON Web Token is part of RFC. That's a request for comments 7519. That's an internet IETF standards document there. And actually, within the RTF, within the document, the RFC, it's actually, it says you should pronounce JWT JOT. So if you find me saying that for the rest of the talk, then I still mean JWT or JOT. That's what it is. It's got an abbreviation and an abbreviation's pronunciation. That's cool. But there's more abbreviations. It's not just JOTs that we're talking about. Actually, we've got JWS, JWE, JWK, JWA. None of these come with actual pronunciations in their respective RFCs. But what they mean is JSON Web signing, encryption, keys, and algorithms. And they all form together as part of these RFCs that kind of, as you can see, are counting up 75, 15, 16, 17, 18. JOT was 19 to Jose. Yes. This is JSON Object Signing and Encryption and is the subject of RFC 7520. Oh, God. I am so sorry about that. That's pretty much the worst way to explain anything, I'm sure, and now you probably do just want to get on with the film. So let's start again. JOT. What? I want to cover a few things today with JOTs, because I think they're important little tokens. They're useful little beings, and I kind of want to make you use them sometime, someplace. I'll tell you why later. So as part of this talk, I'd like to tell you what JOTs are, what you can use them for, which is of course pretty important to you, how they work. I'd love to, because they come out as like strings of text, and randomized looking strings of text are kind of opaque. They're difficult to deal with. However, I'm going to blast that apart for you and show you exactly how they all work. And then finally, just show off some of the pitfalls and things you might want to watch out for if you ever decide to use JOTs within your project, or are indeed made to use JOTs within projects. So what is a JOT? This is from the RFC. I thought it was quite a nice, neat little sentence. JSON Web Token, a JOT, is a compact URL-safe means of representing claims to be transferred between two parties. Now, some of that doesn't necessarily make sense, and you need to read more of the RFC, and I highly, highly recommend reading RFCs, because they will put you to sleep. But this is important. It's compact. It's not that big. It's URL safe. You can put it in a URL. That's cool. And it's a means of representing claims, and you can claim anything you want to, and you can transfer those claims between two parties, a server and a client, or two servers, or people out in the streets with cards. I don't know. This is what a JOT looks like. The line breaks are in there for readability. It would normally be one long string. But it does mean things, which is exciting. It actually comes in three parts. The pink part up the top is a header. We have a blue bit, which is the actual payload, our actual claims that we want to make about this. And at the bottom, we have a signature, which actually signs the header and the payload. And we'll see, as I said, how that works later. In fact, this is what that header and payload are in that particular JWT. So we can expand the pink and blue bits there to this. And it's just two JavaScript objects, two JSON objects in this case, which tell you the algorithm that's been used to sign it, what it is, a JWT. And then this claim simply claims that I, as the subject, have the email address philnash@twilio.com. That's all true. But JWTs are pretty much a bit like a passport in a way. A passport has kind of open data. You can absolutely easily see this from this. I'll show you how in a minute. But this data is open to read, just like a passport. And it can be used to kind of transfer and cross borders. And so the thing about a passport is, it's sent to me by the UK government, and because the government kind of made it, it's verifiable by other governments, other border forces, to say whether I am or am not allowed in the country yet. We'll keep the Brexit jokes for later. And a JWT's very much the same. It has these claims about a person, about their identity, and about what they can do. And that person can then present it to, say, a web service or something like that, and the web service can check it and can say this token is correct due to that signature. And a passport will have that similar sort of way of checking. Every time I go through, they put my passport into a little machine under their desk, and then they look at the screen, and then they look at me, and then it's okay. That's fine. And so JWTs are very much like that. So what can you use them for? Because this is important as well. The one at the end is the one I really care about, but I want to give you a few options with this. First up is stateless sessions. And if you are building single-page web applications, then maybe a stateless session is of interest to you. Because you can put all your session information inside a JWT and then give that to the user. And then it doesn't matter. You don't need to maintain a session database on your server at all, even if you have a server or not, as we've been talking a lot of serverless and other people's servers today as well. But within that JWT, you can say, this person is allowed to do this, this, and this. And they can actually read that and say, I can do this, this, and this. And then pass that back to the server when they want to perform something. So you can have stateless sessions. All the session can be in the JWT itself. It can be used for a microservice architecture. This is quite an interesting one. I am not a microservice architect, so I won't spend too long on this. But if you have an authentication server within your architecture that actually allows and permits other servers or a server to do things with other services in that architecture, then if you hand up a JWT and sign the JWT using, in this case, an asymmetric keys, then your service can then use those services that the JWT said. It could. Let's move on. OpenID Connect. OAuth 2 is great, and OpenID was a lovely idea, but when they came together, it actually ended up as quite an interesting article. So this is about the third go-around of OpenID and trying to make a real, proper federated sign-in system. Finally dealing with actual kind of real third parties that people use now, rather than having to come up with existing new OpenID servers and things like that. So OpenID Connect basically works over OAuth 2, but the token you receive as part of OAuth 2 is a JWT, and will come with all the scopes and things you're allowed to do as part of this token. And finally, and this is the one that I like because it's what we kind of use it for at Twilio, is client-side authentication for third-party services. So you have a client, you have a JavaScript client, or even an iOS or Android application, and you can't leave your API keys inside that application there, because people will steal it, and then they will use your account, and you will run out of money. So, using a JWT, we can actually give access to our users on the client side, and be able to, on the API side, be able to verify that this user could actually make this happen in the API. I have a little demonstration of that, which you can go and join if you want to. I built a little emoji chat, which is under that URL. So you can only send emojis through it. If anybody wants to join in, I'm going to click that and... Yeah, okay, it's loading, that's a good sign. I'll show you how this works later, but I'm going to send an emoji. No. Not that one. Let's send my favorite emoji, which is 2 beers, because 1 beer is just not enough. Actually, I've opened multiple tabs there, but it came up on... No, it's not. It's there. Oh, I see. I've lost my slides. There we go. So that's just a chat, but the chat is powered by Twilio's chat API. And that is just provided to you as an SDK, a JavaScript SDK that you use in the browser. And in order to authenticate a user with that, to be able to send messages to Twilio and to the other chat rooms, you need to provide a JWT for that user. So that's all about what we can do with it. But I'm sure you're kind of wondering at this point, how do we go from 3 bits of text with 2 dots in it to some kind of idea of what people can achieve and what they can do and how we can verify that? So let's see. Well, let's look at creating a JWT. We're going to start with this code. In fact, I'm actually going to grab it, and instead of going through the slides, let's build this as we go. So I have that there. So let's just drop into a node REPL. And we're going to create ourselves our header and our payload. This is the exact same one as I've been using on the slides, so we can see how it comes together. And so we need to encode both of these. We encode the header and the payload in URL safe base64 encoding. URL safe base64 means that normal base64 encoding has slashes, pluses, and equals in, and those are not URL safe characters. So URL safe base64 removes the equals because they're just padding, and changes pluses to dashes and slashes to underscores. So let's do that. We're going to create an encoded header, and that is going to be done with a we're going to use a buffer. We're in Node.js here, so we can do stuff like this. We're actually just going to stringify the header itself, make a buffer out of it, and then turn that back from bytes into a string that's in base 64. Hey. So that's it, and you should recognize that from the slides. What's nice to see is you should definitely recognize the EYJ, which is curly brace in base 64. Let's do the same for the payload. For the payload, we actually want to take off some equalses because they will arrive and we don't want them. So if we go back through there, we want to turn the payload, not the header, and call it encoded payload. Cool, and you've seen that before as well, right? Let's see if we do have that somewhere. Where's our JWT gone? We can talk about claims. Let's talk about the claims, actually. Then we'll get back to it. Cool. So we've seen some claims. And as I said, this JWT is about being able to claim things about a user and a person. We have a header. This claims things about the actual token itself. In this case, the token's type is JWT. I'm not entirely sure what else you're supposed to put in there, because they're JWTs and the type is JWT. I don't know. You can also have the algorithm that's used to sign this token. You can say, I won't sign it. This is useless. Because if you just send around information that anybody can change any time, you're asking to be hacked. So you can secure it by saying, I tell you what, in order to verify, in order to sign this token, we'll use the algorithm that is, in this case, HMAC SHA-256. You can use higher numbers of that. They're 350, no, I won't say that, 512. There are other algorithms as well. I'll mention them later. But this one is the kind of default one that most people use. But inside the payload, there are a bunch of standard claims which you can make, and I'll just run through a few of them quickly. So is, and this is because we see these 3-letter keys in this case, because it is a compact token, and so it's part of the JWT standard is very much about having very short keys, at least for the default ones. So we have the issuer. This is the application that has issued the token. The subject, we've seen that. This is about the person that we're actually making claims about. Audience, so this is what the token is actually meant for. Then we can have other things like expires at, and so this can tell you how long the token lasts, as well as not before. You can't use this token before this time. And issued at, which tells you when the token was actually made. All very useful for verifying things over time. And finally, JTI is the JWT ID. This will become useful later as well. You can normally put in some kind of UUID in this because you just need to uniquely identify this one token here. And then you can put anything else you want in it. So you can make any kind of claims that you want about the user, about the resources they can use inside an API or an application, anything like that. So that was our header. And I talked about encoding. That is, as I said, yeah, pluses for dashes in this base64 URL encoding, and slashes turn into underscores. We did that, so now we have to sign the encoded header and payload. And this is the important part. This is the part where we get to include cryptography. Yay! I'm not going to talk about cryptography because it's done for me by this lovely inbuilt Node standard library. And so what we need to do is take the encoded header, a dot, the encoded payload, and then we're going to sign that using a secret that we've come up with, and the HMAC SHA-256 algorithm. So let's see, our HMAC is equal to crypto. We're going to create an HMAC using, as I said, SHA-256, and then the secret, which in this case is secret. Not particularly secret at all, but this is just for demonstration. Now we add to the HMAC there the actual thing we need to encode. So if I just add encoded header dot encoded payload. Template strings are cool, right? And then I just get out of that, we can get the signature is equal to the HMAC digest of that in, again, base 64. And this one's going to come with some equals as well, so we'll just remove those. And there it is. That's our signature. That is the code again on the slides, which will be available later. And as you can see, if you check out the start of the signature there, L9VI, we have L9VI here, and it ends in PQDK, which it does over there. So this is our absolute signature. And we've made a JWT. We've made a JWT. I think that's cool. It's really, it's just encoding things and then signing with a particular function and a secret. That's all you need to know. The other side of this, of course, is verifying the JWT. So if all you have is this, so actually let's go JWT is equal to our encoded header plus a dot plus the encoded payload, another dot, and then the signature. That is our JWT. Cool. So if I just take that now and just quit out of quit out of there and start up a new REPL, I can start from just the JWT. So if you start with that, how do we find out the data about it? As I said, all we've done is encode these things. So first up, we can, using a bit of fancy deconstruction in an array here, we can get out, again, our encoded header, payload, and signature by splitting JWT split on the dots. And that gives us back those parts. And then we just decode those things again. So the header becomes, what are we going to do with this? It's a buffer. Okay, yeah, we need to JSON parse the result of this new buffer made of the encoded header, which is in base 64. And then turn that back to a real string. And that's interesting. We got to parse this. Oh, I see. Turn it to a string and then parse it. We get back our header. We do the same with the payload. And we get back our payload object. And then we're just left with the signature. Now at this point, we don't want to make the signature again. That would be useless. No, that's entirely wrong. We would actually like to make the signature again. We have our encoded header and payload, and we know our secret, so we can generate the secret again. And this is the point at which point you make the signature again, and finally do a secure compare of the signature and the one that you created out of the encoded header and signature, header and payload. So that's it. And then once you've done that, you can tell whether this payload, whether this JWT was the right one or not. And what I like here is there's a playground on this online for this called JWT.io, JWT.io, in which you can debug these tokens. So I have our token right there, our JWT, and it does all the decoding and stuff for us. In fact, because the secret, which is down at the bottom over there, starts a secret in this, you can tell whether the signature is valid as well. So it does all that for you. If you ever have to work with JWTs because some third party has made you do so, and you're not quite sure whether something's working or not, go to JWT.io and put your token inside here, and it will tell you what's going on. Normally, something's been forgotten. You've not told it. You can tell that the user can do something. Of course, just verifying the signature is not quite enough because you need to actually verify some things about it. So, for example, if your decoded payload includes an expiry date, then you probably want to check that that is, not yet expired. Otherwise, you can also throw out the token. And you can check a bunch of claims, the not before, the expiry, and then any of your custom claims that have to do with the actual actions your user has taken. Cool. So that's how you make and construct and deconstruct a JWT. Finally, there are some pitfalls if you decide to go ahead with any of these use cases. First up, as I said at the start, data is public. Like all the header and payload is encoded, and so you can decode it. You have the algorithm inside the header. You know how to even sign it. All you need, the difficulty there is you don't have the key to sign it with. The signing algorithm became a really difficult thing, actually. As I said earlier, you can actually set the signing algorithm to none. So if you're a malicious third party who wants to pass off a JWT as your own and make up some new claims, then you just take this innocent JWT which says, hey, I'm signed with HS256, and you remove that and go none. And the actual spec, and this is where we should ignore a spec for once, the actual spec says that you should, in fact must, I believe, verify the token with the algorithm put in the header. Because if you can change that to none, then that's just rubbish. So always verify tokens with the expected algorithm that the JWT set. Never believe the JWT itself. Don't believe things users tell you unless you can verify them. There is one way, of course, to keep the data secure, and that is to encrypt it as well. And I showed up JWE, JSON Web Encryption, on one of the slides at the start. And that actually does talk about encrypting the payload and the header as well. However, I am not a security expert in any way, and so I recommend that you get somebody who knows about cryptography to deal with that, not me, and probably not yourself. So if we go and look back at what you can use these things for, there's some other things to it. Stateless sessions did have a bit of a difficulty. They sound like an absolute dream, this ability to just tell the user exactly what they can do and then verify that when they tell you they can do it, that they're correct. However, if you ever want to revoke the session of a user, if you have them in a database on your server, it's very easy to just delete that session ID and it's gone. In terms of JWTs, by default, all you can do is wait for the expiry time, and that's it. That's all you've got. Unless, of course, you maintain a blacklist of revoked JWT IDs. And this is where you would use a JWT ID. So you then have to keep a database on your server of the revoked set of tokens, but it's definitely going to be smaller than your actual session database. So it's maybe not the worst thing in the world. On the other hand, there's storage of these JWTs as well. I reckon you should do it in cookies. It may fall to a cross-site request forgery attack. However, any session ID inside a cookie falls to that as well. Some people say you should store JWTs in local storage or IndexedDB within the application, which makes them both vulnerable to a cross-site scripting attack, and also means that your entire application requires JavaScript in order to send that to save the JWT and send it back with any request. Normally, you'd do so as an authentication header. So I recommend cookies as that. In the microservice architecture idea here, what would be quite cool, and what I tried to explain earlier, is that you can actually use public and private keys as well. So we had HS256, the HMAC-SHA algorithm, to sign our key in the first place. But you can actually use the RSA256 and above, which is a public-private key. So in the case of microservices, you want to have your authentication service own the private key, which signs and verifies the original token, and then all of the services can only use a public key to verify that. As I said, I'm no microservice architect, so I won't talk about that. OpenID Connect remains cool. And then client-side auth for third-party services. Like I said, this little chat application I've got here which some people have sent emojis to. Cool, hello everyone. Actually has, of course, pumpkins, that's cool, medicine, hello. So we have a token here. Actually, Firefox, I've got some kind of extension which makes it very difficult to read that. So I'm going to go to Chrome and just pop the token URL in there. And what I think is brilliant about this, somewhat scary about this actually, is that, I don't know if you can read that, but the Google Chrome translates this token, it reckons it's in Polish, and tries to translate it, so I'll just go to the original one, because it's not in English, I don't know. And we can look at this token as well. And this, as I said, this is the token that, that Twilio uses. If we go back to JWT.io here and pop that in, we can actually see a bunch more stuff about what, how we use this. So, for example, on the far side there, you can see that we have a JWT ID there, and we have our own custom grants. So in this case, this application brings up a random username for you. So this one is actually xenophobic Owen Hanover. I hope nobody's too xenophobic. This is my identity apparently. So, oh god. And then it tells you that we can use IP messaging on this particular service. We have the other verification things like the issued at, expires, numbers. So this is when it was made and how long it lasts, who issued it, and the subject. The subject is the account. And what I can actually do here is, and as you can see, this is an invalid signature right now because this was not signed with the word secret. But I have the signature right there, and I can go and revoke that later as well, so nobody can steal that of me. And if I pop that in, then my signature again is validated, verified, sorry. And this token is a real token. Cool, let's get back to the slides. So that's JWT. That's JWT tokens and what they can be used for. I hope this makes a little bit more sense at the end than it did at the start, and that you now know how you can take apart 3 bits of a token like this and turn it back into a header, a payload, and then work out whether that's a real signature. And finally, just if I can leave you with one thing, then JWTs are just like passports that we can go and use to prove things about ourselves. So with that, I will put a link out to the slides on Twitter as soon as this is over with, which has a bunch of these links as well. It's very useful for you. And that's all I have for you. My name's Nash. I'm a developer evangelist for Twilio. Thanks very much for joining me this afternoon.
Applause.